Page 147 is what we are open to in our books. Our warm-up is remembering some key features of graphs that we have done before. We know these things. We're going to remember we know these things. And then we're going to bring back some old stuff we did with parabolas, like domain, range, increasing, decreasing. And we're also going to add a couple of new stuff to it today also, okay? So we're going to figure out how to know if your parabola opens up or opens down. So this warm-up, look in here. This is not in your books. This is just on the screen. What is the vertex of this parabola? Is it going to be 1, 7, or is it going to be 7, 1? 7, 1. Good. My x has to come first, right? So the vertex for this parabola is going to be 7, 1. All right. How about my x-intercepts? What are you confused on your vertex? Your vertex is your highest point. The highest point on the parabola is your vertex, where it turns, which is at the point of x is 7 and y is 1.
Oh, that is. I thought it was negative.
Okay. Yeah, that's just tick marks on the y-axis. X-intercepts.
6.
Okay, but I would count that wrong if you just put 6 and 8 on the test. 6, 0. And 8, 0. Remember, there's 2 of every number, right? There's a y and an x in each one. So make sure you be specific at which one we're talking about. All right, how about the y-intercept?
Wait, yeah, it's 1, right?
It's crossing the y-axis at 1?
Oh, no, wait.
It's crossing at the origin?
What?
8.
It's touching at 8?
No.
Can you see the y-intercept?
No.
No. A y-intercept would be crossing over my y-axis. I can't see when it's going to happen. It's going to happen down here somewhere, right? So it's going to be negative something, but right now I can't see it, so I don't know. Okay?
What would you put down?
So we are going to be able to find out what it is going to be. Okay? But in this case, looking at this particular graph, we cannot see it. And with the skills you have right now, you would not be able to tell me what it was. Okay? So there is one, it's just not visible. All right, draw a line. Whoever's clicking, please stop. Draw a line on the graph that shows that the parabola is symmetrical. So where would I draw a line? Would it be, let's do this, would it be vertical or horizontal? What would cut my parabola in half?
Oh, vertical.
A vertical line would cut it in half, right? Where does that vertical line need to be?
In the middle.
Where's the middle? Someone said it's 7. Good. I need to cut it through the middle where x is 7. Symmetry means it's the same thing on both sides. I could fold it, if this was a piece of paper, and I folded it on the red dotted line, it would lay on top of each other. It'd be like a mirror image. Okay? You ever like stood on like in the middle of a mirror and like stuck your arms and legs out? It's fun, you should do it sometime. Looks like you're jumping off the ground. It's fun.
I usually snap it.
This is what happens when, you know, back in the day when phones weren't there. We used our imaginations and did stuff. Didn't go brain dead. Alright. Here we go, this guy. Again, what is the vertex? This one is on your paper now. What's my vertex? Brandon. Where is the turning point of this one? It is at 1, -1. Okay? Would we call this vertex a maximum or a minimum?
Minimum.
A minimum, good, because the turning point is below everything else. All right, Joe, how about my axis of symmetry? It's kind of a trick question.
Okay.
It relates to one of the things we just did. Think about where we said it was symmetrical.
Like the line?
Uh-huh. -1 and is, well, not -1. What's going to cut it in half this way?
1.
The positive 1. Is that an X or a Y? It's an X. So for axis of symmetry, we say X equals 1. If I draw a line where X equals 1, that's what's going to cut my parabola in half. All right, Jenny, how about an x-intercept? Just give me one of them.
2, 0.
2, 0. Oh, excuse me. 2, 0. Riley, what's the other one? 0, 0, yeah. So it crosses through my origin, and it also crosses through the point at 2, 0. Courtney, how about my y-intercept?
0, 0.
0, 0. Yes, so the origin for this becomes my x and y-intercept.
Wait, how did you get the axis of the symmetry one?
So that's the line that's cutting it in half. So if I cut it in half, I'm crossing over where x equals 1. That's where it's going to cut. Questions for me? All right, you try the next graph that's right below it. You're going to try this one. All right, Miss Shauna, what is my vertex? -1, -1. Beautiful. And I'm going to jump to Sierra. Sierra. What is my axis of symmetry? Okay, and is it the x or the y that's cutting through at -1? X, yes. We're cutting through where x equals -1. Good. Mason, x-intercepts.
No, because it doesn't cross that.
Good, we don't have any. There are none. Okay, this one does not touch the x-axis, so we don't have any x-intercepts. Kevin, y-intercept.
0,
0, -2. Good job. We good? Coming back? Yes. Slowly. So graphs like this, it's not a real world problem. It's kind of just a graph by itself. We've also put it with real world stuff, which is what my next one is. So next one, asking a bunch of questions again, but now I have a rocket. Okay? So we're going to remember how to interpret pieces of my graph. So instead of just saying vertex, I want to know, what does the vertex mean? Instead of just giving me an x-intercept, I want to know, what does it mean? Okay? So, we have a rocket being launched off the ground, and it gave me a graph. And it even labeled some points for us. How nice. All right, what is the y-intercept? What you got, Jaguar? It is 0, 0. Good. And what does that mean? The rocket started on the ground. Good. So y-intercepts show us where things start from. This rocket started from a height of 0. All right, Brennan, how about an x-intercept?
0, 0, and 12.
All right, 0, 0, and 12, 0. Good. Elijah, what do those represent? When it comes to the rocket, what does that show about the rocket? Okay, where it came down. Good. Jenny.
It shows that it was, like, it took no seconds to, like, where it started.
Okay. All right, and then it's showing you what at the end. What does the other one show you?
When it hit the ground.
When it hit the ground. Good. So our x-intercepts, in this case, they show us when the rocket is on the ground. So if I asked you how long did it take to hit the ground, you would tell me
12 seconds.
You would tell me 12 seconds. Good. So on the x-axis is showing when it's on the ground for the rocket. Because both y values are 0, so that means I had my 0 feet at both of those pieces. All right, maximum height. Walter, what is the maximum height of the rocket?
625.
Don't leave numbers naked.
Feet.
Feet, good. 625 feet, good. Sermons. What about when? When will I reach that?
6 seconds.
6 seconds, good. So the vertex, it does have 2 numbers. Remember, your x is your time, your y is your height. So pay attention to what part of it is asking of you. Old stuff, right?
Yeah.
Remember? Good. We're going to go into increasing and decreasing. We've talked about this. I think it's been a hot minute since we've talked about it, but we have. So if I'm asking you, when is the graph increasing? I'm going to cut it in half. Because do we agree the rocket goes up and then it goes down?
Yeah.
So I'm going to cut it in half. The first half is where we're increasing. Okay? I have a couple of numbers out there. It's asking me when. So am I looking at my x values or my y values?
Why? Wait, no. X is the seconds.
X is the seconds, right? So looking at when is it increasing? So between what time and what time was the rocket going up?
1 through 6.
Where did the rocket start, guys? 0 to 6.
Oh.
So the rocket was increasing between 0 and 6 seconds. You could write out the sentence between 0 and 6 seconds. This is showing you interval notation.
Sure, I might as well just write seconds because I'm probably not going to remember that.
That's fine. I will say EOC, they'll probably have it written like this as like an answer choice. So just make sure you can recognize that that means the same thing. Okay? All right, when are we decreasing? So that's the other half. So it's asking me when again. Okay, so I can't just say after 6. I have to say between 6 and 12 seconds. Good. If I just say after 6, that means, 20 seconds later. Well, no, 20 seconds later, it's probably still sitting on the ground. It's not really moving. Stops moving after the 12. All right, your favorite, domain and range. All right, domain, is that X's or Y's? X's is range, X's or Y's. Y's, I'm going to show you something. I'm going to draw like a barrier. So I'm doing domain first, right? So I'm going to draw a line on my x-axis where it starts and where it stops. So there's my first x, there's my last x, right? So if you need something else to help you with this, here's another strategy. So looking at my barriers, what are the x values in between? Between the red lines, what are the x values? It starts at 0 and it goes to 12. So your domain is 0 to 12. So it's all the x values that are on your parabola.
Do we have to put the cable too, like one?
Yes, because they are part of the function. 0 is where it starts, 12 is where it stops.
Yeah. So wait, because I was writing some exercises, like, how did you get the domain again?
Domain is your x's. So I drew a line where my x's started and where my x's stopped. And so I drew those lines through the x-axis. So it went from 0 to 12. So range, I'm going to cut through the y-axis, right?
Yeah.
So I'm seeing there my y's start down there at the bottom, and then my y's stop up here. So I'm cutting through the y-axis this time. So what are my range values? 0 to 625. Yep. So I've kind of drawn a grid around my graph. All right, we good? All right, here we go. Here's some new stuff, okay? There are two ways to write the equation of a quadratic function, okay? There is standard form, which we are used to, the ax squared plus bx plus c. Today we're going to also see vertex form. What do you think is shown in the vertex form?
The highest point, like, of the graph.
The vertex, right? Vertex form is going to show me where the vertex is. So it's going to give me that turn point in my graph. Okay. Standard form is ax squared plus bx plus c. And this all equals y. There we go. And our vertex form, probably should show it to you. Okay. It's going to be y equals a times x minus h squared plus k. Right? What do these two equations have in common?
That they're both equal to y.
Both equal to y. Good. What else?
They both have an a in the first part.
Both have an a. They're both squared. There's an x somewhere.
Is that an h or a b? That's an h.
Yeah, it's an h. Okay. Good. So they have a lot of things in common. Okay. What's different about vertex form?
There's parentheses.
There's a parentheses, and there's an h and a k.
Yeah.
So what part of this do you think is the vertex?
The K? Wait, no, the H.
The H and the K.
Yeah, more.
The H and the K are going to give me my vertex. Okay. Notice in my equation it has x minus h. Okay. Just the h by itself is my x coordinate for my vertex. So if that said x minus 2, 2 is the coordinate for my x. Okay. If it said x plus 2, then it turns into negative 2. So your x is going to be opposite signs each time we pull it out. Okay. All right, they both share an A, and guess what that A does? It tells me if it opens up or down. Project time. This A value, which is in standard form and it's in vertex form, the A value tells you if we open up or down. So get out your project papers. Look at your equations. Elijah, what is your A value? Negative x squared. Jenny, what's yours? What's your A? What's the first piece of your equation? 2x squared. Abby, what do you have? Negative x squared. Shauna, what do you have? Negative x squared. Blonder, what do you have? Negative 3x squared. Rami, what do you got? What's the very beginning? Negative x squared. Brennan? Oh my goodness, you don't have a positive? Am I speaking all the wrong people? What do you have? 2x squared. What do you have? Just an x squared. Just an x squared. Okay, so what do you think is going to tell you up or down if A is positive or negative? Okay? So if A is a positive number, think about it. If you're a positive person, do you smile or do you frown?
You smile.
You smile. So if A is positive, your quadratic is going to smile at you. It's going to open up. Okay? So right now, if you just have a positive x squared, positive something x squared, I would write next to it, it's opening up, and I would draw that little symbol. Okay? If A is negative, negative people frown a lot. So your quadratic is going to frown at you. It's going to open down. Okay? So go ahead and determine which one your graph is going to do. It's also going to narrow down your examples that you made yesterday at the bottom. So you made some of each. So if you know your graph opens up, all your examples are open down, you can't use anymore. Okay? So opening up could be the rocket being launched, kicking a kickball, hitting a golf ball, throwing a basketball. That's all opening down. Okay? If your A is positive and your parabola is opening up, that's things that dip down and come back up. So a roller coaster, a bird flying underwater, a submarine. Yes, those are all the dipping down ones. Okay? Once you determine what your graph is doing, you can put it away. The A value will also determine if you are going to have a compression or a stretch. Okay, so once you determine up or down, put it away. Later, you're also going to figure out if your graph has a stretch or a compression on it. You won't do it yet, but that's where you're also going to get that information from. Okay, your A value will tell you that also. So like some of you had numbers in front, right? That number is going to tell you something else about it also. Okay, so what we're going to do today is we're going to look at the graph and we're going to write it into vertex form. Okay, when I look at a graph, I see a vertex. I don't know what you're doing, but it has to stop. It has to stop. Whatever you're doing has to stop. We talked about how important that paper was. So maybe you put it in your folder.
Oh, I did. Oh my gosh. Slow, dude.
Maybe that's where it is. When we look at a graph, we see a vertex, right? We can see the vertex. We also see other different points on the graph. What we don't see is the value of A when we look at a graph. So I have to actually find the value of A before I can write it into vertex form. Okay? When I write the equation of the whole graph, your x and y stay there because that's showing for every x and for every y. This is the equation of my parabola. Okay? So we have to solve for A first, then we'll rewrite our whole function. Okay? So, still doing the rocket one. we are going to substitute my vertex in, and we're going to pick a point to replace my x and my y. That way my a is by itself, and we can figure out what a is. Okay? So, what is my vertex? This is the rocket. What was my vertex? 6 and 625. That means 6 is my h, and 625 is my k. Alright? We need to pick a point. It doesn't matter which one. They have a couple of them labeled for us. How about the point 0, 0? Do it later, please. How about the point 0, 0? Sound good? You could pick any point. I like to pick easy ones. I think 0, 0 is going to be pretty easy. So I'm going to use the vertex, and I'm going to use the point 0, 0. So using the point 0, 0 means I have a value that I'm going to plug in for x and for y. So instead of y equals, now it's 0 equals. I don't know my a. That's the whole point. We're trying to find what a is. Times x, which is now 0, minus h. H is 6, so it becomes minus 6 squared, plus k, which is 625. All right, PEMDAS. What is, so parentheses first, what is 0 minus 6? Negative 6. Now my exponent, what is negative 6 squared?
36.
It's positive 36. So it becomes 36a plus 625. And we're trying to get a by itself. What am I going to move over?
Move over to
The 625. We're going to subtract it over. And then our very last step to get rid of that 36, we will divide. So we have negative 17.36 equals a. So now I have the pieces I need to plug in. I need an h, I need a k, and I need an a value. Okay, those are the numbers we're going to plug in. So I have y equals, what's my a value?
17.36.
Negative 17.36 times x minus h. What is h? 6. So it becomes x minus 6 squared plus our y value of my vertex is 625. Okay? We leave x and y in my function because we're showing this is the equation for all the x's and all the y's on the graph. Yes, ma'am.
With that, can we round it to negative 17.4? Do we have to?
You could. You could. The more you round, the less accurate it is, technically. So that's why we like doing 2, 3 places. But you're not wrong. Okay, so looking at this equation, I can tell you, oh, there's a negative out front, it's going to open down, and my vertex will be at positive 6, positive 625. And all those are true of my graph. We good? Yeah, next. Okay, we have a new, and if you needed to keep writing, it's on the board. We have a new parabola. Let's just look at it. What are 5 observations you can just tell me about this new parabola? Key features about it. What? The graph? Well, part of it's going down. The other part's going up, right? So it starts off by decreasing. All right, Abby, what do you see? Okay, it's a positive parabola, so my a value is probably a positive number. What other key things you see on this?
A y-intercept.
A y-intercept, where is it at?
It's 4.
Mm,
Oh, 5?
it's 5. Mm,
Yeah.
it's 5. Okay, what else do you see? We
And
see
that's
a,
intercept.
okay. All right, if you see a vertex, what is the vertex?
3, -4.
It's at -3, -4. Good. You said x-intercepts, Mason? Where do you see x-intercepts?
I see -6 and oh wait, yeah, I see -6 and -1 for x-intercepts.
Almost. It's -5 and -1.
Wait, what? Oh, no, I see it.
Yep. So you told me y-intercept. You told me it was opening up. Oh, my domain is all real numbers because we're not restricted to a real world thing.
Yeah.
Okay, so there's no limit on how low or high I can go with my x value, so my domain is all real numbers. My range, right, my y's, they're all above that -4. And then Abby did tell us that A was positive. So I know that's 6 things, but they're all good. So 5 different things about it. Okay. We're going to use some of those to help us write the equation of this graph. Okay. So if I'm going to write it in vertex form, what's the first thing I have to know?
The vertex?
The vertex. Yeah. I'm going to put this in vertex form. Got to know the vertex. And what is the vertex this time?
-3, -4.
-3 and -4. That means -3 is my H and -4 is my K. Alright, I also need a point. I got like 3 to choose from, don't I? I have -5, 0, -1, 0, and 0, 5.
-5,
Which
0.
point do you want to use?
-5, 0.
-5, 0? Is that okay with y'all? Yep, okay. It does not matter which point you choose. We'll get the same A value in the end, regardless of what point we plugged in. So if we're going to use the point -5, 0, then -5 is my X and 0 is my Y. Alright, so let's start plugging things in. Instead of Y equals, now it's what?
X equals. Wait, A equals.
What is Y? It's 0 now. We're using that point. So it's 0 equals, do we know A?
No.
Nope, that's the whole point. Alright, do I have an X now?
Yes.
What is it?
-5.
-5, good. Alright, minus my H. What is H? So I'm going to do minus -3, which means it becomes positive 3. We always square that piece, and plus my K value. My K value is -4. So plus -4 will just be -4.
So is the H and the K value, that's the
vertex.
X and the Y? Yeah, okay.
Yep.
Whatever.
So, yep, the HK is the vertex. Good. What is, let's do our parentheses, what is -5 plus 3? -2. Alright, what is -2 squared? 4. So we have 0 equals 4A minus 4. Then what? I think that's what I used. Nope, it's not what I used. Then we will add 4. And we're going to get an A value of what? An A value of 1. Okay, so on the board, we plugged in the point -5, 0. On the TV, I plugged in the point, what did I plug in? I plugged in -1, 0. Okay, so on the screen, I just did the other x-intercept. Did it matter?
No.
Did I get the same A value?
Yeah.
Yeah, so it's okay. Okay, so my A value is 1. Does that make sense? Didn't Abby tell us A was going to be a positive number?
Yeah.
Yeah, and it is a positive number. Good. We're not done though. We got to put it into my equation. So we have Y equals, it always starts off Y equals when I have my final equation. What's our A value? 1. We don't have an X value anymore because we keep X and Y in there to show all the X's and all the Y's. Minus H is minus -3. That becomes plus 3 again. Squared. And then plus our K on the end, which is -4. So for vertex form, you have to have A, H, and K. Looking at a graph, you'll always know your H and your K. The issue is finding your A value. Questions on that one? I know that can get confusing. Okay, I think we just have beat the test, right? Yeah. All right. So you and your table friends, okay, we're going to go through beat the test. You're checking the things that are true. Looking at the graph, is the y-intercept at 0h? Is the graph, does it have a maximum point at -1,9? Is there an x-intercept at 2, 0? Is the line of symmetry the y-axis? Do I have zeros at -4 and 2? And is the vertex form of the equation of my parabola -x minus 1 squared plus 9? Okay, so work on that together. All right, let's see what we did. Let's see some good stuff.
It was true, I was surprised.
Does this graph have a y-intercept at 0,8?
Yes.
Is that when we're crossing our y-axis?
Yeah.
Yes, it is. Is it written the right way?
Yes.
Yes. My x is 0, my y is 8. So that first one is good. All right. Does the graph have a maximum point at -1 and 9?
Yes.
Yes. A maximum point is also called the what?
The maximum. Or no, the
vertex.
Of
the vertex, right? Your vertex is always your maximum or minimum point. So in this case,
okay, I'll put it back.
in this case, my maximum point is my vertex, so -1, 9 works out for me. Does it have an x-intercept at 2, 0?
Yes.
It does. What's the other x-intercept?
Well, -4, 0.
-4, okay? So one of my x-intercepts is going to be at 2, 0. Is the y-axis cutting this parabola in half?
No.
No, it is not.
Oh, I was right.
What's cutting this in half? Remember, look at the vertex.
Yeah, it's cutting through the x.
What x is it?
Oh, it's cutting through 1. -1.
-1. Yeah. So that's not true. The line that's cutting my parabola in half, it always goes through the vertex. Since my vertex was -1, 9, the x that's going to cut it in half is -1. All right, zeros, x-intercept, solutions. They mean all the same thing. Is that happening at -4 and 2?
Yes.
Yes. All right, they gave me a vertex form, -x minus 1 squared plus 9.
No.
Why not?
God, you had to.
How could we fix it? It is wrong. How could I fix it? According to this, it opens down. Is that true? Does my parabola open down? Yeah, so that part's fine. So I would agree with the negative part. Okay? Remember, this is our vertex, right?
Yeah.
H and K. So if I want x minus h inside of my parabola being squared, that's x minus -1. So what should be inside? A +1. That's the problem. This right here, they didn't change it. Okay? Then they have +9 on the end. Was that my K? Yes. So this is the correct version of it. This was wrong. All right? All right, questions or anything for me? Yes. The domain is all of your x values. So if it's not in a real world like this one, the domain would be all real because I have an arrow on each side. The worksheet you got today, you're going to work on it. You're not going to turn it in or pack up until you get a stamp. Thanks for waiting. All right, range is your y's. So parabolas, since it's turning, they're all going to be above or below a certain y value. Like this one, they're all below y is 9. Yours, I think it's opening up, so they'll all be above something.